Hey everyone, welcome back to the channel. I hope you guys are doing well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So last 3 days there were 3 easy problems. I hope you were able to do it. So yeah, I'm planning to post only medium and hard problems because yeah, anyways easy problems you should be able to do those. Okay. So let's see the set intersection size of at least 2. You are given a 2D integer array intervals where intervals of I equals to start to end and represents all the integers from start to end inclusively. Okay, including both inclusive of both ends. You are given a list of intervals, and a containing set is as array nums where each interval from intervals has at least 2 integers in nums. Okay, so what they want to say is that you see containing set of this whole interval array is something like there should be at least 2 elements in this containing set from every interval. So if you try to see 1 and 2 are the 2 elements in this interval, 4 and 7 are the 2 intervals from this element, and 8 and 9 are the 2 elements in this interval. Okay, so you see this is also a containing set. If you try to see, this is also a containing set as 2 and 3, but you see the size of both of them are different. So you want to return the minimum possible size of a containing set. That is what the question wants. Okay, and yeah, the rest of the things you need to figure out on your own. And yeah, I hope it should be not that difficult. The constraints are also 3000, so you should be able to solve it in n square also, but yeah, I will try to show you definitely n log n method. Okay, so yeah, let's see uh, what we need to do exactly. You see, the first things, what are the first things which should come to your mind by looking at these problems? Okay, so first thing is that you are given some intervals. Okay, you are given some intervals, so they might be overlapping or they might be anything. Okay, they might be given in a random order. Okay, so now if you see, if you take two intervals which are side by side, okay, so what do you want to do? You want to select the, let's say this is interval A, this is B, and you have let's say 3 elements in common between A and B. Okay, let's say there are 3 elements common, so you would want to select any 2 of these 3 elements into your set. So let's say you have a set or you have a vector, okay, in which you are putting your elements. Okay, this is your containing set. Okay, so whenever you are putting your elements, you will try that they should belong to as many intervals as possible. That is, they should uh, take account of the future intervals also as well as the current interval. So among these 3 only you will be needing to select. Okay, so what is your first observation from this problem is that we should select those elements which has more chance of being covered in future intervals also, more chance of, let's say you are scanning these intervals one by one using the iterator I equals to 0 till I equals to n minus 1. So let's say you have n intervals, and as you are scanning you should select those elements which has more chance of being present in future intervals also. So if you are at I, you should select it in such a way that it is present in future intervals also, that is I plus 1 or I plus 2 or something. Okay, being present in future intervals. Okay, so yeah, this is the thing. Now what can you devise a very greedy method to do this? Definitely, if you are having a interval, which element should you select? So that, let's say you are having no intervals before this, let's say you are going to select the first interval, which element should you select to for that, so that you make sure that your selection has a more chance of being present in future intervals? Definitely it should be the last 2 elements. You do understand, right? So you do understand that in a, if I think it in a greedy way, uh, I will try to select the last 2 element, so that after this, let's say there are these intervals or something intervals like these elements should be able to cover in those intervals also. Okay, so that is what I will just tell you, that you should select. So in other words, the first, what is the implication of my first observation? So this was my first observation, okay, but what is my implication of this? So this implies that try to select the last two elements. Okay, now definitely the intervals, since they are present in a haphazard way, there is nowhere told in the question that they are sorted or something. You definitely need to sort it. Okay, so now how should you exactly sort this? What do you want primarily? Okay, so you see, you are bothered about the end point of the interval. You see, you want to select the two elements from your endpoint, right? So you are bothered about the endpoints of your interval. So what do you want exactly is that you should sort the intervals in such a way that it should end first. Okay, so the intervals, so basically your second observation will be the intervals which end first, okay, should be present in my processing earlier, in my processing of, let's say, from I to n minus 1, as I told you, as I processing the elements in my processing earlier. Okay, so yeah, intervals in which the end, I mean, I hope you do understand, right? The intervals which are ending first. Okay, so there are many intervals, so I want the ones which are ending first to be present at the first. Okay, so yeah, so that I am able to do my greedy job properly. Okay, now what if two intervals are equal, ending at the same point? Okay, so you try to think about this. So let's say there are many intervals present in the beginning and at the end also, but in between you find two intervals which are ending at the same point. Okay, so you notice that these intervals ending on the same point, and now you try to think that, hey, if they are both equal, then which one should we try to take first? You see, you should be taking the one which has the small length, okay, or which is ending more further. Why? This is the one you should be taking at first. Why? Because you want to see there is some interval before this also, and let's say you have selected these last elements or some elements in this interval. Okay, now in order to satisfy this interval, you would want to select something like, if you know that if you select these two elements from this interval, then definitely these two elements will also contribute for this interval. Okay, and now definitely you want your overlap to be as farthest as possible. You do not want any of your overlap, so that, yeah, so because you see, if you try to do something like, see, if you have this interval, let's say, and then you have two intervals like this. See, this is very important. Okay, someone, if you see hundreds of explanation, they will just tell you blindly that, hey, you need to sort it by the endpoint, and if they are equal, you just select the one which is greater starting point. But why exactly we will do that? Okay, so if you have these two element, you will, when you are processing from left to right, you will select, hey, this element is also contributing to this, so I will select this. Okay, and you will end up in selecting this element because, and you get only one contribution, to this particular set, so to this small set. Okay, but uh, if you process this element first, if you process the larger element first, okay, but what if you process this smaller element first? What if you process this smaller element first? It will see that, hey, there is no intersection between the previous element and this element, so I will try to select these two elements and they will directly take care of both of these. Okay, so there will be no error, unlike the earlier case. Okay, I hope you do get it. Please try to draw it on your own and take some examples and try to understand. Or if you still not convinced, you can choose to take, you can sort it in such a way that only sorting by the first element and then take whichever, like if there is L to R, you are sorting by the end element, that is very sure. And if they are equal, you can try to select the element with which is smallest and try to see what error is coming. Okay, maybe then you will understand what I was telling here. Okay, yeah, I hope you did understand right now also. There should be no difficulty. Yeah, so you do understand that first of all you need to uh, sort by endpoints. So I want the intervals which is ending first, okay, which is ending first. I want those intervals. And if endpoints are equal, select the larger starting point. This is the larger starting point which will give me a smaller set, and it has less probability of being intersection with the previous set. That is why I am choosing to select this, so that yeah, it will just take account of both of these sets on selecting last two elements. Okay, so but you cannot select when there is an overlapping with the previous set. You cannot directly select the last two elements, right? Which would not have been possible for this large set. Okay, so if endpoints are equal, then you select the one with larger start point. Okay, I hope you do understand what I'm trying to say. And yeah, I will also show you, like you do not need to write any comparator function or anything like that. Okay, I will show you how to do this very simply. Okay, so what is the core logic? What should be the core logic? If there are two intervals, if I am processing, let's say this interval, okay, if I have selected two elements, so in my set, if the last two elements which are selected are present in, let's say this is L, this is R, okay, so this is the last element, this is the second last element, right? So if my this L is greater, if it is greater than the last element, what will be my interval looking like? This will be looking like this. Okay, so there is no contribution from the previous elements into this particular cell, so you need to select these last two elements. Okay, if L, if the left interval is greater than last, select last two elements, select last two elements. Okay, and there, if there is any one intersection, so if L is, let's say, greater than, if it is not greater than last, if it is equal to last, or equivalent, if it is greater than second last, you can just select the last element only one, select last element only, because one element is what you understand by this. There is a set which is looking like this and it has one contribution. So if I am processing this particular set and it has got one contribution from the previous set, then only this last element you need to select. Why will you select two elements, right? You need total of two elements, so one you already have, so you select only one element from the right. So select the last element and you see that's all. That is all of your algorithm. And yeah, now comes the sorting part. I told you that you need to sort by the endpoints, and if the endpoints are equal, you need to sort by the larger starting point. Okay, so endpoints you need to sort by, but they should be in ascending order, and you need to, if the endpoints are equal, you need to sort by start point, which is in descending order. So without using comparator function, how you can sort it? It's very simple. You see, if you use normal sort, what it does is that it by default sort by the first point, and if the first point are equal, it sorts by the second point, all in ascending order, right? So if you are sorting an array in ascending order, you know there is a function which sorts an array in ascending order. You can just negate all those numbers, that is multiply all of those numbers by -1, and tell the function to sort again and remove the -1 later. You will get a descending order sort. I hope you do understand what I am trying to say, right? So that logic you can use. So what you can do, if there is an interval L to R, you can swap this R to L, and then again you do what? You do R minus L. So from this you do two conversions, you swap it and the next element you just convert it, then and you just sort this whole element. you just sort this whole array, and what at the end what you will get is sorted by this particular thing only, sorted by the end point in ascending order and sorted by the start point in descending order. So yeah, that is what we will do. You see, this should be, I guess, simple only. Okay, so intervals dot size, you are having this, and what do you get is that first you try to swap the elements. So for auto x, so I will take the address of auto x intervals. What will I do? I will try to first swap x of 0, x of 1. Okay, so I'm swapping, I'm iterating through each and every intervals and swapping this. So this operation is performed now, swap operation, and the next operation is that negate the second element. Okay, so what you do, you can just choose to negate this second element. So yeah, you got it, and yeah, just perform a simple sort after this, no need to think anything. Okay, so this dot begin intervals dot end. So yeah, you got it, I guess. So you have the elements now sorted properly. Now what you want to do, as we already discussed, that if you are processing the intervals one by one, right, and for the first interval there is no interval to before this. Okay, so you blindly select the last two elements. Okay, for the first interval. So what you do, you keep your vector answer. Okay, or you call it set, vector of set. So since the definition is containing set, that's why I just keep the name as set. So you can do simple things like set dot pushback, and you want to select the last two elements. Okay, now note that intervals now has orders, not L to R, it has something like R comma minus L, some things like this. Okay, so if you want to add the last two endpoints, it will be nothing but R and R minus 1. Okay, so yeah, it will be the first element and the first element minus 1. So intervals of 0 0, the first element of the interval, you select this R, and then R minus 1 also, that interval minus 1. So yeah, I hope you should be able to do this. Control C and V you can do, and yeah, so the lesser number you add first and the larger number you add next. Okay, that's how you do. And then you start iterating from the second element, right? For the second element you start iterating, and you can just check for conditions. So you check for L, you see the L, how to extract the L right now. Okay, so it is present in the second element of this intervals of I of 1, and you need to negate this also. So minus of interval, that's how you will get the L. And R, how you get? It's very simple, you get it intervals of I of zeros. Okay, so you get the L and R right now. So there can be just true conditions right now. Okay, so what are the last and the second last element? So just extract those also, so that you can use them. What is the last element? It is nothing but this set of, you can just call it set dot size minus 1. And what is the second last element? You can just have another variable second last, which is set dot size minus 2. Okay, so right now you are having this last and the second last element, and what were your algorithm? If L is greater than this last element, so it means that there are the two intervals are separated from each other, right? So if L is greater than the last interval, you don't have to do anything, you have to just simply push back the last two elements. Okay, so set dot push back. What exactly are you trying to push back? This R and R minus 1, right? So R minus 1 you should put first, and yeah, and next you should put this set dot R. Okay, and else if you see, if L is equal to last, or L is just greater than second last, I will tell that this is a more strict criteria. So if L is, see, this is the last, last and second last is this. So if it is greater than last, it means that it has no intersections. But if it is just greater than second last, it means that there is one intersection. Okay, so if L is greater than second last, okay, so this means that it current interval has one intersecting element with previous. Okay, uh, or for this you can say that current interval has no intersecting element from previous. Okay, and for if it is one intersecting element, what you want to do, you should not push this r minus 1, you should simply push this r. Okay, that is all. You see, there is another case also where the current interval has two intersecting elements with the previous. So it's something like if the current element which you are considering already has these two elements with the previous, then you do not need to do anything to this interval, you can just be blind. Okay, so you do not need to do anything. So basically do nothing for the third case, do absolutely nothing, and at the end you can just return set.size. That will be all for this solution, I think. So let's see, let's try to run it, and if there is any error we will try to debug. Let's see. See, the n is just 3000 and you are able to solve it in n log n time complexity. So yeah, you get the accepted thing, I guess. If you choose to submit, I hope this will work just fine. So yeah, it just works fine, and you see the runtime complexity, it's amazing, it's 100% beats, and memory complexity is also quite okay. So yeah, I hope you did understand this problem. Yeah, no comparators involved, and a very simple explanation of why you should do this algorithm. And yeah, I hope you do understand why we need to sort it like this also. Okay, so yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.